Say hi and open your eyes to
Hello.
everybody. All right, we have Celeste and Alan here, and then Maximus. You're disconnecting somehow. You may have to move to the family room. Okay. All right. And let me go ahead and do this again. Welcome back, everybody. So today we're going to be talking about circles. We got Marcus, Celeste, and Alan, and Max here with us. And one of the things that we're going to discover is that with circles, for some of you that's gone through transformations, this is very good. For others, this is going to be very new. But let's start with, Marcus, go ahead and read the vocabulary term. Standard form of an
Vocabulary
equation of
term.
a circle.
Standard form of an equation for a circle. An equation of a circle with the center hk and the radius r is x minus h squared plus y minus k squared equals r squared.
Cool, pretty interesting, right? Hey, one thing that I'm able to guarantee is that this equation makes a circle. And for some of you, you're probably like, huh? Now, let me go ahead and explain. A circle, since it's created using a circular motion, it would make sense that two things are even. So one thing is that if you notice this part and this part, they kind of look even, don't they? They just interact differently. And with it, a circle also has to have a distance. Now, let me go into detail of what things go in here. And with that, let me go ahead and erase this. And let me kind of go ahead and highlight. Okay, so you see the R right here? That R is the same R that's here. Okay, and then you see this H here. H tells you the position of the X value. Because remember, you got to keep in mind, one thing that's important for us is that this is X, right? That's the X value. And this part right here, let's see, this K is the one that shows up here. And that's our Y value. Okay, so, but you got to keep in mind, hey, so Celeste, what do you call this point right here? Oh, Celeste, you got to click the unmute. Somehow you muted it.
Sorry.
That's okay. So what do you call this point right here?
The center for the equation.
Yeah, that's the center, exactly. So this is the center. So that means that one thing that's important for us is that H and K, similar to like the X and Y, control the center. They control exactly where the location of that center is going to be. Now, Maximus, why don't you go ahead and unmute your phone and tell me, what do you think this controls?
The radius?
Yeah, I know, but what does the radius control?
What do you mean?
Yeah, like pretty much this R right here, is it always the same?
Mm-hmm.
No, the R changes. The radius is different amounts. That's the reason why it's listed as an R. So what ends up happening is that this R will tell you how big the circle is. So let me give you an example. If this was 3, guess what it's going to look over here? You see how this is R squared? It will be 3 squared. So guess how what's going to show up like this? On the equation, it's going to show up as a 9. Okay, so that's the reason why we have that. Now over here on this side, let me go ahead and y'all see this H right here? And Max, yeah, Max, let's go with you. Max, give me the number for H. 1 through 10.
8.
8?
Mm-hmm.
All right, so that means that by you picking 8, you basically are moving this to the right 8. And the thing that you got to keep in mind is that they go in as opposites. You see that? All right, now Marcus, give me the number for Y, for KM, sorry.
Okay.
Yeah, for K, give me a number for 1 through 9.
1 through 9.
Yeah.
7.
7. Okay. All right. So you just made this thing move up 7 units. So keep in mind that if this was our equation, The radius would be 3. The h, and let me erase some things on here to make it look better. Okay, so this is what it would look like. Your center would be 8, 7, and your radius would be 3. Okay, so this is how this works. Okay, now let me go ahead, and now let's go to this part over here to kind of show you better how this works. Let me screen share. Let me get back to, see if I can do it this way. Should be able to do it this way. Here we go. Let me hit, let me show something. And for you at home, you could pull up this application. I just went to Desmos. Can y'all kids see Desmos right now? Yeah? Okay, good. Hey, so look at this right here. And actually, let me go ahead and build it. Okay, you see how there's no circle? Okay, now you see this equation, x squared plus y squared is equal to, Marcus, give me a number.
7.
Okay, so guess what it did? It just went ahead and made your circle. You see how you pick a radius of 7? Okay, guess what the square root of 7 is? 2.646. You see that? Now let me show you the other part. You see how it says 2.46? That's because right now the distance from here to here, the distance from 0 to this point right here, is that amount, 2.646. Now, if you would have picked a nicer number, give me a number, Celeste, a whole number. So let's say, click on mute. Click
A
on mute.
whole number.
Yeah, give me a whole number.
4.
4? Now, so you notice, remember how this thing went in as this, let me go back, let's see if I could do it on here. Well, it's kind of hard to do on here. Remember that this was squared? So guess what the radius is? 2.
It needs to be in the video.
Okay, so in this case, the radius is 2. All right. Max, give me another perfect square.
9.
9. So guess what the radius is?
3.
3, right? Okay, good. So let me, let's go ahead and I'm gonna take away this equation and I'm gonna bring up this equation that I have here. And actually I'm gonna do R and I'm gonna add a slider. And one thing that I'm gonna do is that I should have called this H. And let me call this K. So it will be consistent. Okay, so now we have H and K. All right, now, hey kids, why do you think that this is over here right now? Why is the center, where's the center at in this case? What is this point right here?
1, 1.
1, 1, right? Yeah. And Marcus, if I wanted to move the center from here to, let's say here, 2, 0, what would I need to do?
You would have to change h to -1 and k to -1.
Okay, well, right now it's -1 in a way.
Okay, +1.
Well, here, look,
Okay.
this is the K part. Here, let me move this up because
Change it to 0.
well, if I change this to 0, look what happens. That's 0, kind of. See if I could do it with my finger, it works a little bit better. Right there's 0. And this is 0. You see how the K controls up and down?
Mm-hmm.
Look at the H. The H controls movement from, like right now, H is right now, this is 4. You notice how I moved over to the right 4? Because remember, it goes in as an opposite. So if I wanted to move to 2, I will have to make H2. You see that? Now suppose that, so let's say if I wanted to move it up here, what would I have to move?
Okay, you will need to make the K go up.
Yeah, how much? Tell me when to stop. There, right? You see how K's 2? Okay, Max, suppose I wanted to move it over here to 4, 4. What would I need to change?
The K to 4 and the H to 4.
Good, K to 4. So see how I moved it up to 4? Okay, and let me move this to 4. Okay, Marcus, Suppose I wanted to make the circle bigger. Because right now, it only has a radius of 1. If I wanted to make a radius of 2, what would I need to do?
Change the R to 2 or 4.
Okay. Which one is this? Is it 2?
4.
Does that make a radius of 2 right here?
No.
No,
It'd
right?
be 4.
It'll be 4, right? And why is it 4?
Because the square root of 4 is 2.
Yes, exactly. Because remember, in here, in this equation, this is square. And actually, one of the things we wanted, if you wanted to, I could actually make this square, and then you could talk about it in terms of R. So like, if I make that square, notice how the radius now, you made it 4. Right now, the radius is, I think it's 16. And see, so like if it wanted a radius of 2, now it would give me a radius of 2 because I added that square to it. So keep in mind that, but I'm going to take that out. But this is kind of how the intro of standard form of circle starts working. So now let me go back to our original, let's go back to our original file, our smartboard file. Okay, let's see, let me click screen. Let's go back to our smartboard and let's actually work on some problems. Now that we know how now that you feel safe on how this works, let's actually talk about some of these problems that are here. Okay, let's see. We move down. All right, so let's go ahead. So let's start with Max. Max, if I wanted to identify the values of H, K, and R, what would I do? Actually, let me change colors. H, K, and R. Can you identify those values for me? What would they be?
Well, you got to do the.
What is H?
7.
Yeah, that's H. What is K?
-3.
Good. And what's R?
Square root 3 power 2 or 9.
Well, right now R is 9. Now, when it goes into the equation, that's something different. And then you sometimes have to play with transformations, right? Now, let's go ahead and see if you were right. Yeah, H was 7. This was supposed to be a 7 right here. This is supposed to be a -3 in that box, and then it's supposed to be a 9. All right, so we start off that way, right? And then if you put into the equation, notice how it looks like now. Remember, it goes in as a 7. Hey, notice on this one, you see how there's a minus and a -3 right here? And you see this 9 here? So notice how this gives us a solution, where now this is x minus 7 squared. And this now, hey, does everybody see the 2 negatives right here?
Mm-hmm.
Now, Celeste, do you remember what happens when you have 2 negatives? When you multiply 2 negatives, it becomes a positive. Like, hey, Celeste, and the reason being is this. Let me create a quick number line. And this is a reminder for everybody. So you see -1? Okay, so what's the opposite of 1, Celeste?
The opposite of 1 is -1.
Good, so what's the opposite of -1?
1.
Exactly, so that's the reason why. Remember, the opposite of a negative, that's the reason why 2 negatives make a positive. Because you're taking the opposite. So when you take the opposite of -3, you get a +3 as a solution. So this is the benefit we get from this. So this is the reason why this becomes a +3 and this is a square. And then Marcus, what happens with the 9?
It gets squared.
Yeah, and it makes the value of 81 as a result, right? So then we discover we have this 81. So then you would just see this as the equation. And from here, you got to be able to eventually work backwards and master that. Okay, if you see 81, 81 means r squared, which means that r is 9. So you notice how r is 9 and r is 9 here.
Is
And then you got to
9.
be able, yeah, and then when you look at this 3, you got to be able to pull out the opposite and then say, oh, I really got -3 here. And then you have to look at the -7. Okay, pull out the opposite, that's 7. So do you notice how we work backwards on that? This is a skill that's going to be important for us to do. All right, so now let's go ahead and move on to Celeste. Okay, Celeste, so how would the equation on this one look like?
Well, so H will be 0,
Good,
will be 4, and 3 will be R.
good, yes. So this is what it will look like. You see in the equation how there will be -0, -4, and then you got the 3 squared. And once we squared the 3, Celeste, what is that? What is 3 squared?
3 squared,
Yeah, what's 3 times 3?
9.
9, exactly. So this becomes 9. And this remains as this. Okay, Marcus, why don't you do the next one? What does the next one look like?
Oh, so you would have parentheses x plus 2,
Mm-hmm.
and then,
Yes.
you know, plus 8, and the
Okay.
radius would be 4 squared.
Yeah. So then afterwards, this one, it's going to be +2 + 8, like you said, and then 4 squared is going to be the 16, all right? All right. Now let's see. Max, do the next one. What does the next one look like? Oh, hold on. Things started bugging out for a second. All right, do D, Max. What is D going to look like?
Like all answers, or you want me to find out?
The equation, son. What's the equation going to look like? Okay, it's going to be, yeah. You see this? It's going to be x minus 2, y minus 6,
Yep.
and then 12 squared. So it's going to look like this in standard form. And on the last one, let me go ahead and just show you the last one. The last one, it's going to be about x minus 3, y minus 2, and this one is going to, now take a look at this one. You notice how, now the only thing I want to point out about this last one that's going to be important for you, you see how this one was the square root of 10? So Marcus, what happens when you take the square root of 10? What happens in this
You
part?
get a weird number.
Actually, you don't. It
It
just ends
cancels.
up happening that the square and the square root cancel.
What?
And the reason why they cancel out is this. This is really, remember, oh, hold on.
Oh, that thing, sorry. Square root of 10 squared?
Yeah. Remember, you see this, a square root is really a half. So these cancel out. So that's the reason why you get 10. A square times, it's like 2 times a half becomes nothing, right? So now let's go ahead and now move on to this one. Now, on this one, they're going to give us a circle, and it's going to be up to us to identify what the standard equation of the form is. So this is circle A right here. Now, Marcus, tell me some of the things you need me to do in order for you to give me the solution to this one. What do I need to
So
do?
we need to see where the center is.
Okay, good. So you want me to find the center for A for you?
Yeah, which would be -3 and -4, right?
Actually, I think it's -4. Because you see how this is about -4,
Oh,
right?
yeah,
Here?
-4, sorry.
And then I want to say that this is -4, -4.
Yeah.
All right, so the center, and actually let me write a little bit better because it looks a little messy there. The center is going to be -4, -4, isn't it? Okay, good. So, all right, so now you have the center. What else do you need?
The length of the radius,
Good.
which is 2.
So R is 2, good. Okay, good. So now what would the equation look like then?
The equation would look like x plus 4
Mm-hmm.
squared plus x, no, plus y plus 4 squared
Good.
equals 2 squared.
Yeah,
4.
which is 4, right? Good. Okay.
Mhm.
All right. So Max, why don't you go ahead and do B? What would you need for me to do B or for you to solve for B? What do you need? Okay, Max, I didn't hear you. Say again.
First, find x and y for the center.
Okay, so find the center first, right? Okay, so
So
what do you think it is right now, just by looking at it?
I think x is -1,
Okay, -1, and what else?
2 for y.
Okay, good. And then what is the what else do you need?
The radius. So
Good.
1, 2. Is it 4 or 3? I can't tell.
It's gonna be 4.
Okay.
Okay, good. So then what is the equation gonna look like?
So it's going to be probably parentheses x plus 1
Good,
plus y minus 2
good.
equals
And what?
4.
Equal to
Oh,
4
wait, no.
squared.
16.
Yeah,
4
so it'll be
squared.
16. Good, 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 good. So basically, it's when you see the R4, you have to square it here to get the standard form. Okay, so now Celeste, why don't you go ahead and do the last one? What do you need to solve for C?
You're gonna need the X, Y.
Okay, you need the center. You need the center of C. So you just say, you want the center. Okay, so let's look at the center. The center is going to be 3, -3. And what else do you need, Celeste?
Y,
You need the radius. Okay, and how much is the radius there? The radius is going to be 3. Good. All right. So now, Celeste, go ahead and tell me, what is the equation going to look like?
X plus Y minus 3.
Well, it's going to be x minus 3.
No, Y.
Y plus 3, because remember, they go in as opposites. Okay,
Oh,
so they go in as opposites, x minus 3, y plus 3, and then the radius is 3. So as a result, we'll do 3 squared, which is equal to 9 as a solution. So we have the benefit of getting this. And this equation will give us that solution that's there. All right, good. Okay, now let's go to the next page. Okay, and let's do the next one. Okay, now on the next one, Marcus, let me go ahead and have you read the instructions for us. Marcus, listen, also sit up, because I really don't want you to go to sleep right now. I don't want you to be closing your eyes. You understand that? Okay. Now go ahead and find me go ahead and read example 3.
Hi.
All right.
Yes.
So, okay, go ahead and read example 3.
Find the center and the radius of each circle, then graph the circle.
All right, good. So what is, give me what you would do.
Well, just take 2 and the 3 out of the equation because they're just h and k.
Okay,
So the
good.
center would be 2, 3.
Okay, so the center
Then
would be,
I would square root 9 to get 3.
and then you would square root 9, and you would get the radius of 3, right?
Yeah.
Okay, good. So then if you could graph this, what would it look like?
So it would be where 2, 3 is, and then it would be 3 with it long.
Good.
6
So
long.
this 2, 3 is here.
Yeah.
And then you will then count out 3 each side.
Yep.
Right? So this is 3, that's 3, and you do that. Okay, good. Max, why don't you go ahead and lead us? How would you do this one, the next one? What would be the solution for the next one?
Do it again?
Yeah, what's the result? Like, how would you discover the answer for B? Because remember, they want you to find the center, the radius, and graph the circle. So center, radius, and graph the circle. So how would you do this one?
So x is 1,
Well,
y is -5.
yeah. Okay. So H and K, because remember we use HK because it's movable. It's the X. Yeah. So it's the center. Okay. Good. And then what is R?
2.
Good. How'd you come up with that answer?
I just did it backwards.
Okay. So you did basically when Marcus talked about you take the square root of 4, you get 2, right? Okay.
Yes.
Good. So afterwards you would graph it. And you would then come up with 1, -5, and then come up with a radius of 2 from each side. Now, typically when you do this, you would count 2, 2, 2, and 2 from the center. And then that's how you're able to get the solution. All right, now let's go ahead and scroll down and see Celeste. Why don't you go ahead and read this one? What is it? Read the directions.
Write the standard equation of each circle.
All right, good. So Celeste, if you're going to write the standard equation, what's the first thing you got to do?
Find the center of the circle.
Good. All right, so this center is going to be 3, -4. Okay. And then what is the radius? Can you tell what the radius is, Celeste?
Oh.
Yeah, so the radius is 2. Okay, good. So what is the equation going to look like?
X plus 3,
Good.
y minus 4.
Yes, x minus 3, y plus 4. And then what is the radius going to look like?
Equals
4, because remember, you would take the radius and square it, and that's how you would get that result. All right, good. Okay, Marcus, why don't you lead us through the next one?
Okay, so the next one is really easy because
Okay.
it's on the origin line.
Mhm.
So it would be 0 and -4 for h and k, and the
Yes.
radius is 6, isn't it? 3?
Yeah, actually, it's going to be
The radius,
3.
isn't it? 3?
Yeah, radius is 3. Yeah, this is written wrong. That is 3. Okay, but now
So
give us the equation.
parentheses x minus 0 parentheses squared plus
So
y
sometimes, let me stop you there real quick, Marcus. Sometimes
4.
when it's 0, they'll just write x squared. Makes
Oh
sense,
yeah,
but
that's
either way
smart.
is right. Yeah, so either way is right. And then keep on going.
3 squared, which would be 9.
Yeah. Well, y plus 4 squared and then 3 squared. Yeah. So this should be 9. This is a mistake on these notes. That should be 9. Okay, good. So now let's go ahead and now do the next one. And on the next one, all right, Max, why don't you go ahead and read the instructions?
Sketch the graph of each question.
Okay, Max, I think you bugged out a little bit, so retry it again.
Sketch the graph of each equation. Find all the points of intersection of each pair of graphs.
All right, good. All right, so Max, how would I do this then?
You combine them, I think.
Well, you graph each one. Now remember, in this case, you're gonna graph first the circle, and in graphing the circle, you will come up with this, that the center, hold on a second, this thing's just, oh my God, my print turned off. The center is this, -2, 0, and the radius is 3. So when you do this, you're gonna graph that first. And then afterwards, as a result, then you're gonna graph the line. See the line in blue? Okay, so this is what's gonna look like when you graph both of them. Okay, so you have a circle, and let me kind of retrace the circle right here with red. Here's the center. And then, let me see if I could do it better than what they did here. So here's a circle. And let me see, right there. Okay, and let me move it a little bit so it could be a little bit better. So there's your circle. That one has a radius of 3, because I could guarantee you that that's 3. Okay, and then afterwards you graph this line that goes through here. So remember, keep in mind, this is going to be our y-intercept, this part right here. So we're going to start at 1. And then you see how you have a slope of -1? Your slope was -1, so you'll have -1 over 1. So as a result, you'll go down over, and it would intersect in two places. And let me see if I could draw a line here. Intersection would be here, in this location here, and then this location over here. So as a result, one of them is going to be, so Marcus, give me the intersection point.
It would be 0, 3, and
Well, one of them would be 0, 1, wouldn't it? Oh, not 0, 1. Sorry, wrote that wrong. Remember, where was my mistake at? One of them would be
0, 3.
1, 0.
1, 0. Why?
Yeah, because right here, this point right here is 1, 0. Remember, your origin is right here.
Oh, sorry. Yeah, that.
Okay, no, that's all right.
I thought
And then
the
the
center
next
was the origin.
one, yeah, the next one is kind of written on there. I think you were looking at -2, 3. Okay, good. All right, now, let's go with, oh, you're up next. Okay, so Marcus, how would I then graph the next one?
So you would put the center at at 1, 1. Sorry.
Okay, good.
And you would square root 25 to get the radius of 5. So you make a circle with the radius of 5.
Excellent. All right, so we're going to start with this. Okay, so just like you said, I'll start with the center, which is going to be then, you said it was 1, 1, right?
Mm-hmm.
So here's 1, 1. And then afterwards, I'll go ahead and try to draw the circle better with the radius of 5. Let's see. Gonna move it, have to move it around a little bit, I think, to make it fit good. Right there. So there's a radius of 5. Okay. And then what would I do next? Okay.
You would draw the line that is y equals x plus 1.
All right, good. So then that'll be this one. And then, hey, listen, Celeste, I need you to go up to your room because in order to have better sound control. All right, so then you're right. So then I would make this line here and I'm retracing it on here. And this would then give us our points of intersection. So like in this case, we'll have one of them here and one of them here. And those 2 points, once you look for them, you will find out that it's 4, 5. Oops, let me hit undo. You'll make the discovery that this is 4, 5 and -3, 2. Now, the other thing you could do is that you could also go back to Desmos and use some of the program that's there. And it'll be easier to draw these and actually point on there to find out what the actual result of that is. Okay, good. All right, hey kids, I thank you so much for joining us and for doing all this. Okay, so let's go ahead and say bye to everybody. Okay,
Bye.
and hopefully this helps in understanding standard form of circles. Thank you so much for watching. Okay, bye. Okay, kids. Thank you, kids. Love you, kids. We're going to go ahead and just use the equation pi times diameter. And then from there, we'll go ahead and get this circumference, which is 6.3 times pi. So we'll get this as a result of 6.3 pi. All right, now let me go ahead and scroll down. Now, our very last example, and this being the one that is, it's easy to understand, but there is a process that goes involved. Now, the thing they want us to do is this. They want us to go ahead and find the length, find the length of each darkened arc, and leave it in terms of pi. So in order for us to do this is, all right, so let me ask Marcus, how would I find the circumference of the circle?
By timesing 9 by pi. Multiplying 9 by pi.
Well, close. 2 pi r, because it's a radius. So we would do something like this. So you're right, as far as using 2 pi. Now this is the thing. We were practicing right above that this results in 18 pi, right? Okay, but that's the whole thing that's black. Now that's not the part they want. They don't want the whole thing. They just want this little piece right here that I'm doing in red. Okay, so in order for me just to get a fraction of it, I need to express everything in terms of just that little piece. So you see right here where it talks about, let me move this more out of the way. You see this little portion right here that just talks about the 20 over 360, the one I just circled? Okay.
Yes.
That's going to be the fraction. So really what I'm doing is that I'm saying, okay, so out of the 360 degrees that's here, I'm saying, okay, I don't care about the rest of the circle. I'm going to delete the rest of you, and I just want your fraction of what that is. So what they do is this. They multiply in order, so what they do next is this. So Marcus, what's 20 times 18?
360.
Yeah, 360, right? Okay, so you notice how you got 360 divided by 360? So let's say, what is 360 divided by 360?
1.
1, exactly. So that's really just 1 pi that's left. All right, good. Now let's move on to the next one. So this next one, all right, let me move our cells for a second and move this thing so we can see our cells a little bit better. Okay, maybe I have to move it over here. Okay, all right, so on this one, so let's say if I wanted to find the circumference of the circle, what would my slide do?
You would do 10 centimeters times pi.
Close. Now remember, you see how this
Twice?
is a radius? Oops, hold on, let me go back.
Hmm?
Yeah, since you see how this is a radius right here? This right here, this 10, the one I'm pointing to?
Mm-hmm.
Okay. So we will use the equation 2 pi r, right? And then you put the 10 in there. So Marcus, what's the circumference of the total thing then?
20 pi.
Yeah, 20 pi, right? Okay, that's the whole thing. That means that if I went ahead and then encircled the whole thing, I could guarantee the solution of the whole thing is 20 pi. But I don't want the whole thing. I just want a fraction of it. So as a result, I go ahead and place this little thing here. You see how it says 90 over 360?
Mm-hmm.
This gives me that percentage. So Celeste, what's 90 times 20?
90 times 20
Yeah, I'll highlight the answer.
is 1,800.
800, right? Okay. And then Marcus, what is 1,800 divided by 360?
5.
5, exactly. So then this is how we get the result that the solution then becomes 5 pi. Okay, let's go ahead and move on and let's do one more of these. Hold on. There you go. And we use this instead and kind of scroll back up and then move ourselves out of the problem. And on this one, All right, so Marcus, which equation would I use for this one?
Pi times the diameter.
Yeah, exactly. So that part right there, pi times diameter, right? So if I do pi times diameter, what's the circumference of the entire thing?
15 pi.
Yeah, 15 pi, right? Okay. Now, Celeste, do I want the whole circumference? No, I really don't. Remember, you only want this little piece right here. Okay. But if I drew this all the way around, I could guarantee you that all that black is 15 pi. Okay. But I'm going to do something less than that. I don't want 15 pi. I want less than that amount. I'm going to basically remove this whole piece right here. Only find the fraction of what it is. So as a result, you see this 120 that's right here? I'm going to take that 120 and place it here and divide it by 360. And so this is like a third. It's like almost like a pizza. You know, you only take a third of a pizza slice. That's exactly what it means. So what they do, 120 times 15 is going to be 1800. And then 1800 divided by 360 is
5.
5 pi. Okay, good. Now let's read the example. Oh, let me see my little, let me make this, let me create one real quick. Put it down there before we see the solution so we can think about this question. All right, very last question. A bicycle has a diameter of 21 inches. How many inches will the bike travel after 100 revolutions of the wheel? Round your answer to the inch. So Marcus, how would you do this question?
Well, I would first have to figure out the circumference, which is 21 times pi.
Okay, great. And then,
I would just do
so
it times 100.
diameter is 21. Okay, so you know the circumference, right? You just went through this process. You figure out, okay, and what do you do afterwards?
Then I would times it by 100.
Okay. If I didn't know why, or if you had to explain it to Celeste, what would you tell her?
That I think I'll just overcomplicate it.
Oh, well, you just say that one wheel turn is 21, right? Oops.
Yeah.
Right, one wheel turn is 21. And 21 pi, just one wheel turn, right? And then if I do two wheel turns, that's 21 pi, right?
Yeah.
Okay. You would need a total of 100 of these, basically. So it's easier to just do 100 times 21 pi. And that's exactly what we do over here. Right there, where this is 100 times 21 pi. And then afterwards, this is one of the very few times you're going to multiply right here and actually come up with the rounded to your nearest inch, because you're going to get a bunch of decimals when you multiply pi into everything, since pi is your irrational number. All right. Well, thank you so much for joining us. Thank you, Marcus. Thank you, Celeste. Thank you, Max, for having us. Okay. We look forward. Next video will come out on Wednesday.
Thank you. Bye.
Bye.
My computer.